record this, and then I'm going to need the chat window. So that should be all. And we should have that one, yeah. Okay, then I think we're good to go. So again, good morning and welcome to second to final lecture in the Introduction to Programming. And then we will, of course, continue with the advanced programming course after 1 week break. But last week, we talked a bit more about different data structures, a bit more about dictionary and tuple, and a lot more about storing different types of items into lists, just as like strings and floating point numbers, but also storing lists inside lists, which we sort of realized that it's a great way to store matrices. And then we talked a little bit about references, about basically about lists, using lists as function arguments, and the fact that when you pass a list as an argument to a function, then the function can change the list. And we talked about side effects and things like that. So a lot of things. Today we're going to talk about something a little different. And what we're going to talk about is basically, at least at first, file operations. And the reason we're going to talk about this is, of course, the fact that it's quite common that when you're writing a program, you're going to need to process a lot of data. And using input is a great way to get little data from you. So if you need like 3 values or name and address or something like that, then it's great. But if you need a lot of data, if you have like hundreds or thousands or millions of data points which you would need to somehow process, then you're not going to ask your user to type them in one at a time, hopefully, at least. And a really typical way to handle data in programs is to read data from an external file, and then maybe process it, and then maybe write it back to another file or something. And what we're going to talk about today is using text files or reading text files in Python. And text files are sort of simple to manipulate in most, or in Python and in some other programming languages as well. And what we mean by text files is a file that contains nothing but text. So I have an example file. Let's see, something like this one. So it's just text. Let's have some English text over there. So now it's important to make a difference between text files and binary files, and important to realize that files such as ones you create with Microsoft Word, for example, are not text files, because there's a lot of other data that are there as well. So there's all the formatting, and there might be pictures and tables and whatever over there. And manipulating or processing those is always more complicated. And typically, if you need to process a binary file like a Word file, we typically use an external library for that one, which we're going to talk about more next week. But if we have a file that contains text only, like the files you create with Visual Studio Code, for example, the processing those we're going to talk about today. Can I move this to thing somehow? No. Yeah, that will work. Okay, sorry. So let's start with some basics. Easiest way to, here's an example with a really simple method for reading the contents of an entire file. And okay, it seems that there's some issues with the mic volume. Let me know if it keeps on doing that. Seem to be facing a lot of technical difficulties today, and my camera isn't working either. Let me know if you can't hear me. Anyway, we're going to start with a really simple example of reading the content of the whole file. And now some things that are easy or are important in this are the location of the file we're going to read. And this is going to be an issue, at least for some of you, when you start doing the exercises. But there are detailed instructions in this week's material on how you can fix them. And some of it may require that you actually mess with some settings in Visual Studio Code, because when you're doing the exercises, it's a bit different than when you're writing a program yourself and reading a file. In this case, the file I'm using is on the same directory or same folder than the program I'm using, so it's sort of simple to read. So what we do, let's write the program first, and then let's talk about what happens over there. Something like this. And let's see what happens when we execute the program. And now we see that if we take a look at the file again, there are 2 lines and an empty line at the end. And when we look what the output of the program is, it just outputs all the data in the file. If we change the content of the file, like this, for example, and then we execute the program again, then it outputs all the data in the file 1 line at a time. And if we take a look at the example in here, it's basically almost the same thing. There are some new things, and the first one is a keyword with, which we start the block with. And the idea is that this open function in here actually opens the access to the text file. So this open example.txt, or in this case, the open testy.txt or whatever we're using, just opens the access to the file, meaning that after that we can read the contents of the file. There are several ways several methods for reading the contents, but before we can use any of them, we need to access the file, and we use open for that one. And this as keyword means that this is this new file here is a variable where we store something called a file handle. And file handle is used to access the file later. It's like a variable where we sort of store like a reference to the file. You can think about something like that. So then later when we want to access the content, we can use that variable to access the file. And another new thing is this with keyword, which I mentioned before. And the thing with this one is we can open a file and access it without using the with keyword. But we use it because when we use it like this, we don't need to close the file ourselves. And this is important because when we are opening a lot of files, and especially when we are writing files, but even when we're reading them, when you're opening a lot of files, you're spending system resources. And it's also possible that if you open a file and don't close it properly, that you're going to mess up the whole file, depending if something goes wrong, for example. At least some of you in some point of your computer career have probably encountered a case where you had like a USB stick or something, and then when you were writing it, then your computer, I don't know, something broke down, or you removed the sticks too early or something, and then you messed up some of the files. And the same can happen with your hard drive. So it's important that when we're not using the file anymore, we're closing that. And when we're using the with keyword like this, we don't need to explicitly state that close the file, but instead Python does it for us. So that's what we're going to use whenever we are using files in this one. So the syntax in all together, it's like with, and then we're using the open function. We provide the name of the file as an argument, and then we use the as keyword and store the access of the open file or open resource, to be more precise, into this variable. And then we can use the variable to access the content of the file. And in this case, the method we use is called read. This is like the first one. And the idea of read method is that it reads the contents of the entire file, and then it returns it as a string. So we, in this case, we save the content from the file into this variable content, and then we just output it. But it's a string, meaning that we can do anything with that one. We can see how many characters there are in a file, for example, doing something like this. So this outputs 52. There are exactly 52 characters in a file. And this includes all the characters, all the spaces, and all the line feeds, and all the punctuation and whatever characters there are in a file. But basically, this is handy when you have a file that's not too long and you want to get the entire content in a single string. So the read method returns it to you. Okay, if we have a longer file, and even if we don't, I think the most common way to read data from a file is use a for loop. And this is actually quite handy because it means that after we open the access to the file, like we did in here, we can use a normal for loop to iterate through the lines in a file one at a time. So let's try it out first. Something like for line in file, and then we straight something like this, for example. Again, you get the lines as strings. So when we execute this one, now we see that it outputs all the lines one at a time. So hello, hey there, hello again. This is one more line. If you take a look at the, the file, it looks like this. Now, any ideas why we have these extra line feeds or extra empty rows in here? What could be the reason? So if you take a look at this one, we just iterate through the lines one at a time, and then we output word line and then the actual line. Remove the word line from there if it makes it easier. But if you take a look at the output in here, and if you take a look at the actual file in here, what might be the reason that there are these excessive line feeds or excessive empty lines in here? The reason for this one, this might be, the reason for this one is that the text file consists of consecutive characters, like characters following other characters one at a time. And line feed is a single character. Line feed is a character like any other character, and almost all editors can display line feeds like this, that when they encounter a line feed in a file, they display the next line on the next line, or display all the data after the line feed on the next line, and so on. So basically, line feed is denoted with a backslash and n. And before we use this one, I can show it to you. So basically, we could do something like this: first, and then backslash n, and then second. And this one just outputs the words first and second on different lines. So basically, when we use the backslash n in a print statement, it actually shows up as a line feed. And this is actually quite handy. We do something like this, so we get two lines there, two line feeds over there. So yeah, there's a question I have. How does the for loop print out each row in the line? How does it know it's a row? Yeah, it's using the backslash n. So it's actually it outputs. If we take this one back a little bit, I think I have it over there. Yeah, this for loop, it keeps on reading data until it encounters a line feed. So the line feed is an important character in here. So it goes, if you take a look at the file over there, it starts reading, it reads until it reaches the line feed character, which is not visible, but it's in here. Or it's sort of visible. It's visible in a sense that it actually displays as a line feed, but there's a line feed character, so it reads and then it returns the row including the line feed. And this is important thing. And that's why when we execute the program in here, we get this sort of, it looks like there are more line feeds than they're supposed to be, but there really isn't. The reason for that one is that all these lines returned from the file contain the line feed at the end of the line. So meaning this, we could do something simple. Any ideas how to get rid of the line feed at the end of the line? What would you do? There are some like useful functions we haven't talked about, but what would you do by using the stuff you know already? The end equals nothing is. So that's a good point. Let's see what it actually does. Yeah, that one works. That's a handy thing. That's actually something that we didn't include in the material, but that's a good, really good trick. That one works. If you just want to output the lines, then you could get rid of the line feed character. So this is a good one. But if you actually want to manipulate the line, and let's say that you want to process the line somehow, and you want to get rid of the line feed, not just print it, we could do something like take a substring excluding the final character, something like this probably works. Let's see. Yeah, and now in this case, it's important to realize that although we use 2 characters to denote the line feed, like \n, it's still a single character. So if we can take a look, something like if we have a line feed, we can output line feed. So it just outputs like an empty line, and the length of that line feed is just 1. So it's just a single character. We need to use 2 physical characters to denote it because we don't have a line feed character on our keyboard. But this is still a single character, this whole \n. Okay, so that's a handy trick. There's also a method strip which we can use, which is really handy in this one. And what it does, it just removes. Yeah, it did. Yeah, that's a good point. The previous example removed the last letter in line. Yeah, it did. And the reason for that is that because there was no line feed in the final line. So there's no line feed here. If we add a line feed here, then it would have worked. But because there wasn't, then just removing the final character doesn't work with the final line because there's no line feed following the word line here. And that's a really good point as well. You're really sharp today. That's great, because it seems that I'm not. Okay. So the strip function or strip method, sorry, is really useful in this one. And what it does, it removes all the white space from the beginning and from the end of the line. So if there are any spaces in the beginning of the line, it removes those as well. And let's take a look. Let's add something over there and let's see. And we will see that in the second line, there should be some extra spaces in there, but the script also removes those. So now it sort of depends on what you're doing. In a lot of occasions, strip is like the perfect method for this one because we're usually just interested in the text actual content of the file or lines. But if the spaces are important, then you need to do something else. The end thing is great if you're just outputting them. If you need to get rid of the line feed, you can always use something like replace, for example. So let's just replace the line feed with an empty string, and after this one, the spaces are still there if we need the spaces. In a lot of cases, we don't want to have any extra spaces like in the beginning of a line, but in some cases you probably want to have them. It could be like an indentation. If you're reading a Python program from a file, for example, then you probably don't want to strip all the lines because then you get rid of all the indentation as well, if you're doing the indentation with spaces. Okay. Then this kind of method is great for when we have a file, something similar to this one, where we have like sort of like one data point on each line. There's like one string on each of these lines, and we probably want to handle it so that we have each of them as separate strings. But in a lot of occasions, we have something called a CSV file, which is sorted for comma separated values. So we could have, for example, data points like this. So one more. And So something like this is quite typical, that we have several data points in each line. And reading this file is similar to reading any text file. So if we take a look at this one, if we execute it, we can still get the lines one at a time, and we can handle them as strings. But in this case, that's not enough, because we probably want to access the individual data points. So we're not happy with just having a string with these values separated with commas, but we want to have the values from that line. And again, there are several methods we could use for this one, but a really useful one is a method called split, which splits a string into a string list. Let's try it out first. Now I think it's important that we get rid of the line feed before we do that. And then we need to output the values, of course. So in this case, now we have a bunch of lists, and each of these lists now contains the items separated with this separator. So when we use the split method, we need to provide the separator that's been used in a file. And typically when we have these CSV files, the separator might be a comma, it might be like a semicolon, it might be a tab, it might be a space. And whatever you're using yourself, it's important that you're using a character that's not included in the data. So for example, the comma is used as a decimal separator in some places, so that would be a bad separator for the entire data points if it's used in the file as well. So we need to use something else. But whatever you're using, it needs to be something that's not included in the actual data itself. Okay, so this one seems to work somewhat okay. Now we have lists containing the data. Yeah, very good question. Split has a default parameter value for separator. So if you don't provide a parameter for split like this one, then it expects basically white space as separator. So basically mean that spaces are used as separators. So if you have a split, is actually quite useful even if you're not doing anything with files. A typical example could be something like a sentence. Dog ran over the road or something, and you want to get the individual words from that sentence. An easy way to do it is just use the split. So let's split it out, and now we don't need to provide the actual separator because we're using white space. I'm actually used to providing it even when I'm using the white space, because I think it makes it more readable. But if you don't provide it, Python assumes that you want to use space as a separator. And then we can do something like forward in words and print them out. So this is a great way to extract the individual words from a sentence, for example. So it's useful even if you're not doing anything with files. But a typical way to use it, oh, I didn't store that one. Let's get back. Couple of undos. Typical way to use split is when we are dealing with CSV files, because in CSV files we have the data separated with commas. Okay, let's run this again, and then what's wrong with the content? Well, in this case, the separator is all wrong. But what might be the problem with this one? Why may these lists be as useful as they're supposed to be? Yeah, the apostrophes, yeah, so they are strings. So now we have a bunch of data that seems to be numbers. It seems to be numeric data. So if you take a look at it, these are integers, and we probably want to handle them as integers. So any ideas, what would you do? How would you fix it? Yeah, we can use the int function, but we can't use the int function with the entire list. So again, what we need to do is iterate through the items one at a time, and then use the int function for all the items. There are also some shortcuts we can take for this one. I think one is mentioned in the materials, and it's something we're going to talk about. I think might be next week, or it's in the beginning of the advanced course. But then it was something called list comprehension, which is really great in Python for this one. But a basic way to do it in this one is, so we have values, which are like strings, and then we could have numbers, another list, and then do something like for value in values, and then numbers append, and then int value. And then when we output the numbers like this, then we have a list containing integers, which is great because now we can do something like get the sum of all numbers by using the sum function, for example, like this one. So now we're basically able to actually manipulate the data in a form this is probably what we want to do with the CSV file containing numbers. So it takes several steps to actually access the actual data points in this one. So we need to open the file, iterate through the lines one at a time, and then it's always, I think it's a good idea to remove the line feed. In this case, it doesn't really matter because Python knows how to ignore the line feed when you use an int function for that one. Numbers is list defined in here. Yeah. So this is where we define the numbers list in each round. There was a question that numbers. Yeah. I mean, it's a good it's a good idea to have a sort of an extra space between over there. It's easier to see what we're doing. So anyway, then in here we replace the line field, and then we split the data, and splitting creates a string list. And what we need to do is we want to convert all the items in the string list into numbers. So we create a new list for the numbers. Then we iterate through the strings in string list and add them, the converted items, into number list one at a time. So these are basically the steps in here we need to take if we have a CSV file containing data other than strings to actually convert it into usable form. But the good thing is, no, we need to include the first one as well. But the good thing is that this is sort of mechanical. These are the same steps and when you're doing the exercises this week, these are the steps you're probably repeating a lot. There are several exercises where you need to read data from numeric data from a text file, and whenever we are reading a text file, we are reading strings. So if you want to do something other than just manipulate the strings, then you need to convert the data yourself. Fortunately, it's quite easy. I can show you the list comprehension thing, and this is not this week's topic, but just to show you that there's an easier way to do this, we can do something like this in Python. So this basically creates a new list, and then it performs this int value operation for all the values in this list values. But this is something we're going to talk a lot more about in the advanced course, I think. So because there are this one, it can be extended. It's great, but it's sort of a complicated tool. But you can use the for loop like we've been using it before, like this one. It's perfectly fine. There's nothing wrong with this one. It's something you have done before, and I think it's even might be easier to read, especially at this point. So this is perfectly fine. But I think the list comprehension example is included in the material at some point. Okay, then what more? We talked about splitting strings, and now one thing to realize that when you're reading a file, when you open a file, there's something called a file. There's like a pointer which is created when you open the file, and the pointer is used to so that Python knows where you are reading in that file. And that's important that, for example, that when you're using the for loop, you can read the lines one at a time. And the problem with this one is that if you read the content of the file, like this one, let's just read it and output it. And then let's do it again. Then we can see that there's nothing displayed after the again text in here, even though we're doing the same, except we are doing the for line in file again. We don't have the just remove the replace part, so it's exactly similar in both cases. So it displays the lines, and then again it doesn't display anything. And the reason for this is that there's this pointer created in file when we open it with the with statement, or with the open statement actually. And when we reach the end of the file, then you can't start iterating through it again. So if you need to read the file several times, we can actually manipulate the pointer. We can set the pointer back to the beginning of the file, but then again, on the other hand, it's probably just as easy to just open the file again like this one. So whatever you want to use, I think the pointer example, can't remember if we actually included in the material. It was there at some point, and then we probably get rid of it at some point. Can't remember what's the final status, but anyway, easiest way, if you want to reread the same file, do it like this. Or if you need the lines again, then you can create a list and store all the lines into list, and then you can use that list to access the lines again and again. So you don't need to read it. But iterating through the lines in a file like this and not storing them in the list, there's an advantage for this one. And the advantage is that if you have a really long file with like a lot of data, we're only accessing or storing one of the lines in the memory at the same time, meaning that we can read like really huge files with this method, because we don't store the entire file into memory at the same time. If you use the read method, for example, which we started with, then it reads the entire file and stores it into memory. Meaning that if you have a file that contains like 15 gigabytes of data, then reading it with read means that you need to have 15 gigabytes of memory where you can store the file, and that may be problematic in a lot of environments. Then we talked about this removing these extra characters. So we have the strip method, which is great if you want to remove all the white space from the beginning and from the end of the line. So if this is what you want to do, and in a lot of occasions it is what you want to do, then strip is great. But if you just want to get rid of the line feed, you can just use the replace, for example, or whatever you find convenient. Okay, so that's it for about reading the files. But because we can read the files, we can of course write files as well. And writing a file is sort of similar to reading a file syntactically. So now we're going to require one more parameter for the open function. So in addition to the name of the file, we provide another parameter, which is a file mode. So this tells Python that we want to open the file in a specific mode. If you don't provide any mode, then the default mode is R for reading. So what it means is that if you want, we can provide the R in here. You can write it like this, and this is exactly equivalent. So it opens the file and then displays all this one at a time. But we don't need to provide the R because that's the default mode. If we provide W as the mode, then the file is opened in write mode. And now W is a special mode in a sense that if the file doesn't exist, then Python creates it. So let's try something like new file.txt in W mode. And then let's not do anything with that one. So let's pass it and let's see what happens when we execute this one. Now there's this new file .txt which just appeared over there. You can actually delete it and yeah, let's move to recycle bin. So if I execute this one, and again, if you take a look at this file listing, just executing this one creates this new file .txt over there. There's a question: what does pass do? Pass doesn't do anything. I think I probably mentioned that briefly. But the reason we're using pass for this one is that whenever you have like a colon at the end of a line in Python, it means that we start a block. And in Python, the block must include at least one statement. So there must be at least one line in a block. And in this case, if you just want to open the file like this, you want to create a new file and you don't want to really do anything with it, we still need to have something inside the block, and pass is great for that one. It doesn't do anything. It's like a placeholder saying that there's a block in there, but nothing is happening inside the block. So it's important, or it's it's important in Python. It's useful in Python because in Python the blocks are denoted with indentation, and having an empty block like this is a syntax error. See that there's an error stating that expected an indented block. So you can't have an empty block, but we can have a block that doesn't have any executable content like this one. So pass is also useful. Oops. If you're, for example, if you want to define a function and you want to implement it later. So let's say that we're doing something, let's do something useful. Let's do something like whatever it could be, largest item, and then we could have a file name which is string, and this is something we're going to need in our program, but we don't want to implement it straight away. We can have a pass keyword over there, so this is still syntactically correct. We can execute the program, but then we can get back to implementing the actual function later. Another way to create a file without using the pass keyword is to exclude the with part. And now, because this open function returns the file handle, we just add the close function at the end of this one. So this one also works, but well, whatever you want to use, I sort of prefer this one. I think it's more Python-like way to do it, but whatever you want to use. Both examples are included in the material. Now, something really important to realize about the W parameter is that if there's any content in the file you're opening, then it's all overwritten. So let's see an example. Let's see our test.txt, which contains all these numbers. So let's open it like this. Let's execute this one, and now when we open this one, this test.txt file, now we see that there's nothing in it. And this means that you need to be really careful when you're using this one, because if you open the wrong file using the W parameter, then you lose all the content of the file. And this is basically not undoable, or at least it's really difficult to undo. So be really careful with this one. What it also means that I think it's a good idea that when you're doing the exercises, for example, when you're doing exercises where you need to write something into file, it might be a good idea to store or get like copies of those data files before you start writing your program, because you will probably at some point overwrite something that wasn't supposed to be overwritten. You can always reload the exercises from the server, of course, but I think might be easier if you have the files copied under different name on the same folder. So W is shortened for write. Okay, let's see what we can do. So we can create a file in W mode, and so it creates a new file. We can also write data into file. Let's use the as handle again. So let's open it and store it in the variable file, and then we can use the file and use the write method to output something. This is new line in the file, and then let's execute this one. And now when we take a look at this file in here, now there the content appears in the file. So this is like again, not too complicated. We open the file in W mode, store the handle into a variable, and then we can use that variable to write data in the file. This is so nothing too complicated. Let's try something. So does this one work as intended? What do you think? Do you think this one does what it appears to be doing, or? Yeah, that's a good guess. It's override with the second syntax. It doesn't actually, but there's also a good one. Another good answer. We have to specify a new line, and this is what I'm looking for in this one. So if you take a look at so the write doesn't actually overwrite. So we can write several lines, but again, the new line character, the line feed character, is a character like any other character. Meaning that if we want to add a new line in the file, we need to add it ourselves. And the easiest way is probably just to add the \n over there. When we execute this one and take a look at the file, then we have both of these lines displayed as their own lines. Or if you want, we can add several line feeds over there. We can even, and now it looks something like this. So sorry, there's a question. \n inside a string and it doesn't print it out. Now I didn't understand. Can you explain this a bit further?
Hi, Professor. My bad.
Yeah. Hi.
Yeah. I thought it would print out every character in the string. You know, if you here.
Yeah, it does actually, but the \n denotes a new line character. So it's like a line feed. It's like clicking enter on your keyboard. And if you take a look at this one, there are 3 new line characters. There's one over here, and one over here.
So if you want to have a \n printed with the line, just like 2 characters, how would you do it?
Oh, so if you actually want to have the \n, then we need to escape it. So we do something like this.
I see.
And then we have the actual \n. That's a good question, actually, because there are occasions where you might want to actually output the \n and not the line feed. And in that case, you just need to have 2 backslashes and then the n. And then Python, that's called escaping a character. And then Python. How about using the apostrophe? It doesn't really change in this one. We can use that one as well in this one. Or do you mean you can output that one? That's not a problem. You can do something like this. New line in the file. Change the back.
I have another question.
So this one, yeah, please do.
Yeah, if I printed out that sentence with \n, the print output wouldn't show \n.
If I would output this exact one.
If it was a print statement with the same sentence.
No, the print statement also makes a line feed. So we can take a look at this one.
I see.
So if I output something like \n, then it outputs an empty line.
Okay, thank you.
Yep, no worries. So \n it's a bit sort of complicated in a sense that it's a single character that denotes a line feed, but it's still we're using 2 characters, and Python it's still handled as a single character, and it's handled like any character, but then print statement, for example, knows to output a line feed when it encounters that character. So it's like a special control character. There are others like that as well, but let's not cover all of those. Okay, writing the file was sort of covered in this one. There's also another file mode. It's not needed as often, because a lot of times when we open the file, we just want to rewrite all the contents in the file. So if we open the file in the A mode, then the existing content is not destroyed, but instead we can add new content that at the end of the file. So let's see this one. Let's first write the data in the file. Let's see, and now the file looks like this. And if we open in A mode, we don't need to change anything else. And then we execute this again. Then there's new data at the end of the file like this. And if we do it again, we get even more data. So it might be useful in a case where you're, for example, where you're running your program like daily and collecting new results and then storing them at the end of the file. Something like, let's say that you're measuring temperature or something each day, and then you want to add it at the end of the file, so to keep track of all the temperatures during the year or something, then the A mode is useful because it doesn't remove the existing content. The downside of the A mode is that it doesn't create a new file, so the file needs to exist when you open it in A mode. So if you want to create a file, you open the W mode, and after creating, you can of course write data to file as well. If you want to add new data to existing file, then you can use the A mode. But as I said, it is useful in occasions, but in practice, I think it's used quite rarely. Again, it depends on what you're doing. It might be really useful to you. Then when we want to write a CSV file, again, if we need to split the data when we are reading data from a CSV file, then we need to create like splittable data. So sort of like combine the data when we're writing data in the CSV file. Now there are again several things we can do. If we have like, let's say that we have 4 data points, we can just use the F string, like in this case. Or if we have a lot more data points, we can combine them, like in this case, with a for statement. There's also a join statement, which is useful. Let's take a look. So let's say that we have a data like this one. And you want to combine it into a single string. We can use the join statement. The syntax is a bit weird. So we first provide the delimiter character, something like a comma, then dot, and then the data we are going to use. No, we don't do it like that. Then join, and then the data we're going to use. And then if we output the data string, it's now a single string containing the data joined with this delimiter. We change the delimiter. It's something like this. We can use any string in this one. So we could do something like this. So now we have a string first and second and third and fourth, which again, this might be useful in a lot of occasions, not just when you're writing data into file, but again, it's useful when you're doing that. So the syntax is a bit, as I said, a bit complicated to remember because for some reason we are providing the delimiter and then the method sort of referencing the delimiter. But it's useful method nevertheless, I think, and this is definitely easier than using any of the other methods to join the data. So it's useful thing to remember. There are examples of this also in the material. So as I said before, as we saw before, when we open the file in W mode, it empties the file, meaning that if you just open the file and don't do anything with it, whether by using the pass keyword or using a syntax like this, then the content of the file are removed. And if you want to remove the entire file, then you need to import the OWASP library and do something like this. I'm going to talk more about importing stuff next week. So this is just something good to know at this point, that you can remove the files like this. Okay, then I think that's basically about the files this week, about reading and writing files. I think this is not that complicated. I hopefully you agree. So the reading and writing are sort of simple operations. You just open the file, and then if you're reading it, you basically usually use the for loop to access all the lines one at a time. You remember to get rid of line fields, but then a bit more complicated is the fact that you need to, if you need to split the data and then convert the data into correct format. But there's nothing new with those as well. It's basically what you've been doing before. And writing data is, again, you just open the file in a W or A mode, and then you use the write method to write data into file. So in Python, I think the file operations are rather simple, hopefully. It's usually manipulating the data that's the complicated part, like splitting it out or joining it together or so on. That's also what we're practicing a lot this week. Then a little bit about validating inputs, and this is somewhat related or connected to reading and writing files, because reading and writing files are typical examples of operations that may lead to errors. So if you're trying to read a file that doesn't exist, or you don't have a permission to read that file or something like that, then you might get an error, and we need to know how to handle those kind of errors. So when someone else is, for example, using your program, it's your program is not supposed to break down if it's missing a file or something. Instead, it's supposed to show a message to the user that this file is missing, so that the user knows how to fix the situation. But there are a lot of errors that may occur, and here are some examples. Missing or empty input values are typical examples or errors. Negative values, when you are expecting positive values, when you're reading data from user, from file or something, and you're expecting only positive numbers, and then you get the negative numbers. Those might be difficult, for example, if you're using them as an index or something. And then missing files are something I mentioned before. Values that are too small or too large might be difficult. Invalid indices, such as trying to access index 3 in the string hey, is a good example. And this is something you probably encountered when you're dealing with strings or lists, and when you're dealing with indices, it's sort of common that you have a too large or too small index. And then wrong type values, such as strings, when integers are expected. So let's see something similar. Let's query the user for his or her age, and then when we want to use this age somehow, it might be a good idea to. Now let's do something a little different than the example. Let's give your birth year, and then let's see that we did something similar in one of the exercises, I think. So let's say that we want to calculate the user's age at the end of this year based on his or her birth year. So let's call this one a year, and then we can calculate the age by doing something like 2020 minus year, and then print you are 8 years old at end of 2020. It could be 2021, because that's probably the year we're living at the moment, if I'm correct. So let's give this one, and let's say that I provide 1991, and now it tells me that you're 30 years old at the end of 2021. So this seems to work fine, but let's say that we give something like minus 100. What will the program output? Yeah, so it says that you're 20 more than 2,121 years old at the end of 2021. Okay, so we might want to validate the input somehow. So let's do something like if year is larger than, and what could be a good point? It could be larger than 0, but then again, we are probably not assuming that anyone born before 1800 is using this one. So we could try to do something like this. Something like this one. So does this work? What do you think? Yep, let's try it out. So let's give 1900, no, what was it? 1991 again, and yeah, it's 30 years old, that's fine. Let's give -100, and that probably was an error when giving the year. So does this work with all possible inputs? Well, could there be any other errors? Let's try something like, what if I provide 300,000? Yeah, exactly. So now it tells me that I'm negative 200,000 on something years old at the end of 2021. So how to fix this one? Yeah, so we know how to chain these if operators. We could do that year is larger than 1900, and it's also the year needs to be smaller than or equal to 2021. I think safe to assume, again, 2021 might be unlikely that anyone born at 2021 is actually inputting his or her age, but still. So now when we provide 13,000 or whatever was the probably was an error when giving the year. Okay, so does it work with all possible inputs? Are we happy with this one? I think it's a lot better than what it was, because now we are catching a lot of bad inputs. But could there be something we didn't expect? Yeah, great. So many correct ones. So we still have sort of a problem, and again, this is a problem that might happen in real. So I'll give you a birth here, and someone did 2005, which is a sort of valid birth year. Yeah, at least it could be interpreted as a birth year. So what will the program do? Nothing is a good guess. Any others? Yeah, there will be an error. There's an error stating invalid literal for int with base 10 2005. The error comes from this one, the fact that we're trying to convert a string into integer, and Python doesn't know how to. Python only knows how to convert a string containing numbers or digits into an integer. And this one doesn't do. Now, this is problematic in a sense that this is really difficult to sort of catch with an if statement. We could go through the input one character at a time, and for each character check if the characters are numbers only, and if they are not, then decide that we don't want to do it. But that's a bit difficult, and also there might be other errors coming up in cases like this. And for this one, we're going to learn about something new, something about exceptions. And now exceptions in this context are errors that occur during the execution of programs. So something goes wrong while we are running our program. So there are different kind of errors in programming, and in Python there are some things you've been encountering, like syntax errors. So you mistype something, like instead of int I type it's, and well, that's not a syntax error, but let's type something. Yeah, instead of if, let's type off or something, and now hyphen. That's it. Well, it's anyway, it's a syntax error, whatever is the actual error message. But syntax errors are sort of easy to fix in a sense that there's a lot of this colored underline in our program stating that we are doing something wrong. So you're all done this. I'm doing this all the time when I'm typing these examples, and it's like just typing in typos when you're doing like normal text. But then we have errors that happen during the execution of program. And those come in a form of exceptions. And the good thing of exceptions is that we can catch them. So there's a mechanism in Python we can use, which we will state that we try to do something, and if error happens, we catch that error. And the syntax looks something like this. There are two blocks included in this one. There's a try block where we include the code that may throw an error. And then there's an except block following the try block where we catch the error that might happen. So let's say that the error we had in this case was value error. So we can do something like this. And let's do this all in here. So let's try to perform the whole operation of querying for a year and then converting to year and finding out if the year was valid in this one, and then accept that a value error may happen. Let's do this one first, and then let's try it out. Now, if I type something that Python can't convert, like, what was it, 20,103, then we have a value error. Now, this is a really naturally quite poor error message. Instead, we want to type in something like, you need to provide the year with digits only, or something like that. But anyway, we catch the error that happens. So the basic idea of try except is that in try block, we include code that may lead to some kind of error, some kind of exception in Python, some kind of error message. And we don't want to display the actual Python error messages to the final user who is using the program, regardless whether it's you or someone else. We instead, because the error messages, even for you guys haven't been programming for this your 6th week, and you'll learn a lot of stuff, but still, you know that error messages might be difficult to understand. Depending on, in some cases they might be easy, but in some cases it's really difficult to know why you're getting an error you're getting. And if you have a user who's not a programmer, and a lot of people using computer programs are not programmers, then it's important that you provide error messages which they can interpret. So instead of providing a value error, which probably doesn't, if you have a relative who's not a programmer who's using the program, he or she doesn't know what value error is. But if you provide message like you need to provide the year with digits only, or something similar, then the user knows how to fix things, how to use the program correctly. And this is actually whole this testing your programs with erroneous inputs and things like that. This is a whole sort of area of programming, all the quality assurance, all the testing and writing tests and things like that. But these are kind of things you should try to figure out when you're writing programs, that what might go wrong and what should I do if this goes wrong? What is the kind of message, or how should the program behave if this goes wrong? Now, in this case, whether we want to include this if-else part inside is debatable. We can get it out over there. Because again, this int function is the one where the error happens if it happens. But in this case, the problem is that oh, there's incorrect indentation in there, of course. This case, the problem is, well, what happens if I provide a year as a string now? What happens if I type in the value as 20,103 or whatever was the year? Yep. So let's try it out. Just give 20, it doesn't really matter what it is. So we still get an error. We get you need to provide the year with digits only, but then we get also name error. Name year is not defined, and the reason the name year is not defined is because the error happens in here, and when an error happens in the try block, then Python immediately stops the execution in here and continues the execution in the correct except block, like in this one. And that means that this variable year was never defined. I think in this case, including all this stuff in here is fine, because it's sort of states that this is the stuff that should happen only if nothing goes wrong. And if something goes wrong, if there is a value error, then it should be handled in this except block. Some of the typical exceptions, and you see some of these that may happen in your programs. The value error, which happens when you have an incorrect value, like for example, you're trying to convert a string. You have a string, but the string doesn't. The value of a string isn't something we can convert with an int character. Or you have an integer and you're trying to find out if it's I don't know, if it's odd or even, and you have a negative index. So you have a correct type but wrong value. And the type error is what happens when you have the incorrect type, something that you're try to do something, you try to take a substring out of an integer or something like that. And the index error or key error is something you have definitely encountered. Is when you're trying to use an incorrect index with a list or a key that's not present in a dictionary or something. The zero division error is when you try to, well, divide something with zero, which might seem like something that's not happening a lot of times, but it's more typical than you expect. For example, when you're trying to calculate the average of items in a list and there are no items in a list. So the length is 0, and when you try to divide with the length, you're dividing with 0. And then there are several exceptions that might happen when you're handling files. There are examples of these in the material, but for example, you might be missing the file. You might have incorrect file name. You may not have the correct privileges to read the file, and so on and so on. There might be more, if there's more than one possible error that might happen in the try block, you can have several except blocks following that one. So for example, when we're trying to open the file example.txt and read the content, we could catch the file not found error, meaning that this will happen if we can't find the file, or the permission error if we don't have proper permission to read a file. In some, if you're, for example, if you're using a Unix computer, even if you're using a Windows computer nowadays, not everyone has the permissions to read all the possible files in the system and from all folders, and it might be a good idea to expect something like this. Yeah, it's also possible to catch all possible errors with except block and not define the error itself. So we can do something like this. No, with open. What was the name of the file? test.txt as file, and then for line in file, let's output them all at a time, and then we accept error without specifying the specific error, and output something went wrong when reading file, something like this. So now when we execute the program, if nothing goes wrong, then we get the content of the file. If I make a typo in a file name, if a file doesn't exist, what could be test999, hopefully doesn't exist. No, when I execute this one, then I get something went wrong when reading file test.txt. The downside for this one, if you're using except and you don't provide any don't provide the exact exception you're looking for, is something like this. If I try to open the file in S mode, for example, which doesn't exist, even if the file does exist, something like this, then again I get something went wrong when reading file. testy.txt. See if I can execute this one. Or something went wrong when reading file testy.txt because this variable doesn't exist, but Python still catches the error with the except statement. So the except statement is it's a powerful tool if there are a lot of very good point. It isn't specific, so the person executing the program doesn't know how to correct. So I would sort of avoid using except without specifying the error type. Instead, have several except blocks where you specify the exact errors that may happen and then provide suitable messages for each of those instead. Because can we also put several errors in an except block, like except value error or type error? I think you can do this like this. No, you can't. Sorry, I'm wrong with this one. Probably not in Python. You can do this in Java, for example, but I don't think you can accept several errors. If you can, then I'm missing the syntax for this one. But I don't think you can. I think you need to have a separate except block for each of these errors. But I need to check this one because it's something I can't remember ever using. And I think most of the times you want to handle the value error, type error separately. But if there's a specific syntax, I'll let you know. Let's skip that one. Final thing today is about, it's also possible to throw exceptions yourself or raise exceptions yourself. Let's see an example about this one. Let's write a simple function which returns true if the number given is an odd number. Something like this, and then we state that if number is an odd number, then we return true, and if it isn't, we return false. We could of course just return this expression in here, but let's write it like this. And let's try it out. So with a couple of parameters, and now it returns or outputs or returns false for 10 and 9, and for 9 it returns true because that's an odd number. And now we could argue that if we provide a negative value for this one, what should it return? So, okay, it can return false in this case because negative is not an odd number, but that might be a, okay, this is not a good example. Forget this one. Let's do something different. Let's do factorial because it's a better one than this one. It's the only one I can think of. So we have a function that returns the factorial of the number, and we can do it by multiplying a number something like this. I think should probably do the trick. So we want to calculate the factorial of 5. We multiply a number with 2, 3, 4, and 5. We don't need to multiply it by 1, but because it doesn't do anything. And so this would be fine. Factorial for 4 is 24, and factorial of 6 is 720. So it's probably working. At least it's close. Oh yeah, it's true. But one more 2 is actually 1 because 1 divided by, just answering the question in chat room, 1 divided by 2 is 0, but then the remainder is 1. So 1 modulo 2 is 1. So it would have worked for 1 as well. But that wasn't a good example in a sense that there wasn't really error in a way what I'm looking for. But anyway, let's think about factorial again. So this sort of seems to be working. What if now this only works with positive numbers, am I right? So if I try to provide a negative, what happens if I provide a negative number for this? What's factorial of -6? What will the factorial of one function return in this case? I index out of range. No, it doesn't in this case. It's not an error, actually. That's a good guess again. But we're just generating a range, and because we're using the for statement, then it doesn't get past the limit. It just iterates through the range generated. Let's try it out. So it outputs 1. Is 1 the factorial of -6? No. And actually, the factorial of -6 traditionally isn't even defined. We can only get factorials of positive integers. So what should the program, so we can test this out. If number, we're great at this one. This is easy. So if number is more than 0, what should we do? What would you do? Yeah, we can put the rest under the if block, but if the rest is under the if block, then what will the program return if the number is more than 0? It's a function, and function is supposed to return something. So the problem, we could do this one. I mean, you're perfectly right. Let's do it actually. This one. So only if number is larger than 0. What will the program output? Nothing. It will output something, but basically it outputs none. So we can sort of argue that it doesn't, but it's none. Well, is none the factorial of -6? No, it is not. It's not in a sense that none is like a special thing in Python. It's like a non-existing value. So yeah, factorial of -6 doesn't have a value, but it's still not a good thing to return, because if we are using this value somewhere later in our programs, and then we might get a really strange error message, or we might get a strange error message in a really strange place if we just assume that we get the factorial. And for this kind of thing, the best thing to do is actually to throw an error. So we can do something like this. And then don't even need an if. Okay, again, the raise throws an error. So let's see what happens when we execute it now. Now we get the value error, numbers would be larger than 0. Why this is a good idea? Because when a programmer tries to call a function and calls a function with something that the function can't use, it's a good idea to get an error message. This is not an error message intended for the final user. This is an error message intended for the programmer who's using the function in the wrong way. So in this case, it's a good idea to actually create this exception. So because this terminates the program. Now when the programmer is testing this out, the programmer sees that, okay, there was something wrong in calling the function, and now the programmer can fix the program. So again, this is not intended for the final user to see, but this is something intended to note that this function shouldn't be called like this. Okay. I'm not going to talk about those. You can check the material because we're running out of time. Next week is going to be our final week. We're going to talk about modules and then some specific modules like external libraries, things you can use, you don't need to write yourself, like randomness, handling times and dates, a bit more about handling different kinds of files, writing your own modules, and then there are some Python features we haven't covered in earlier lectures, so we're going to talk a bit about those, and then I'm going to give you some information about the exam, like how it's going to work and what kind of exercises we might have and things like that. So do you have any questions now? I think the error thing probably might be a bit more difficult thing than the file handling, but it's something when you've done it a couple of times again, it gets a lot easier. The explanation about if name equals main thing, actually we're going to talk about more about that next week. It's sort of difficult to explain unless because we haven't discussed about the modules yet. At this point, it's important to know that the code you write inside the if name equals main module is not executed with the tests. So you can write your own test code there. You can print things out and things like that, and it doesn't mess up the tests. So, but in next week we're going to discuss in detail why it works like that. But yeah, the basic idea that at this point that it's for testing your own code. But I'm going to give you the reasons why it works like that next week. But as I said, you need to know a bit more about the modules before we can get there. That's next week stuff. Yeah, you can pass exercise without calling your own functions. The tests are always calling. If the exercise is about writing a function, then the test program is calling your functions. So you don't need to do it yourself unless you're told to do it yourself. Actually, I'm going to stop the recording now.